Hello students, myself Dinkar Satonkar again welcomes in this part of the chapter motion from the 9th class physics. In the previous part we have seen some problems related with the speed and the distance traveled. So continue further, in this part we will see some more important problems from this chapter. So one problem has been given here, that is nothing but an athlete completes 100-meter race on a straight track. Calculate the distance and displacement of an athlete during the race. So it's a very simple problem. We have been asked to calculate the distance traveled and the displacement of this particular athlete when he completes 100-meter race in a straight track. Now it's been already given in the problem that athlete is running. Now the athlete completes 100-meter on straight track. So that means the motion of this particular athlete is nothing but a rectilinear motion. So we have seen that the concepts of distance and displacement when an object is moving in a straight line, that means the object is performing its motion in a straight line. So here, since the race track is a straight track, so that's why the distance traveled will be 100 meter and the magnitude of the displacement will also be the 100 meter. So such kind of things will already be given in the problem, that is a track is a straight track, or suppose the bicycle is moving on a straight track. So don't get confused with these types of words. These words tells us that it is a rectilinear motion. So whenever you will find such type of numericals, please see that the distance traveled and the displacement, if the object is not moving in a reverse direction, then distance and displacement will be the same. So here also the distance traveled is nothing but 100 meter, however the magnitude of the displacement is equals to 100 meter. Moving little bit ahead, let us take a look on this second problem. What problems reads over here? Let us see. This problem is important. A rectangular track is 40 meter long and 30 meter broad. A man starts walking from one corner of the track and reaches the opposite corner. Find the distance traveled and the magnitude of the displacement. Now this problem is important because now the track is not a straight track, because it's been already given that a track is a rectangular. The dimensions of the rectangular track it's been given. So it is a 40 meter long and 30 meter broad. A man is there who has started walking on the rectangular track, and he moves from one corner of the track and reaches to the opposite corner of the track. And we have been asked to calculate, when he reaches at the final point, what is the distance traveled and what is the magnitude of the displacement. Now in order to have a better understanding, we will draw a rough diagram. Now drawing the diagram is not an essential part, but it is always beneficial to draw the diagram so that we will have a clear-cut idea about what is expected in the problem. So I have tried to draw that. Let us imagine the rectangular track I have drawn. This is nothing but a rectangular track. It's been already given. Let us imagine that the A is nothing but the initial point, and up to the point B it is a straight. So I consider this as the length of the track up to this point B is nothing but 40 meter. Now since it is a rectangular track, so from B to C, this track, that is the breadth of this track is already given, that is nothing but 30 meters. So I can write here as A to B is nothing but 40 meter and B to C is nothing but 30 meter. Now imagine that a man starts walking from point A, and by covering from A to B and again from B to C, it reaches up to the point C. So this is the first corner of the track, and this is nothing but the last corner of the track, or where the man reaches, or it is nothing but the final point. So we have been asked that what is the distance traveled by this particular man and what is the magnitude of the displacement. While discussing the definition of distance and displacement, we know that distance is nothing but the total path length which is covered by the object, and displacement is nothing but the shortest distance or shortest path, length of the shortest path between initial point and the final point. So here A is nothing but initial point and C is nothing but the final point where the man reaches from point A to point C. So obviously if I calculate the distance traveled, this distance is nothing but AB, this length of this path, and BC, length of this particular path up to the point C. So I can write here as distance traveled is equals to AB plus BC, where I can write 40 meter plus 30 meter, which is nothing but distance is equals to 70 meter. Dear students, whenever you will be solving the numericals, please don't forget to write the units. If you forget to write the units, then you will lose the marks. It is very important thing that whenever you express any physical quantity, that physical quantity should be enabled with the unit. Whatever the unit will be there, please express that unit properly. So here distance is nothing but 40 plus 30, that is nothing but 70 meter. Let us calculate the displacement of the object or displacement of the man. I know that displacement is nothing but the shortest path. So if I join this A and C, this dotted line which I have drawn over here, this is nothing but the shortest path between this point A and point C. There is initial point and the final point. Now if you observe carefully, you will find that if I join this AC, then it is a rectangle triangle. Okay, I know that this is AC is nothing but the hypotenuse, and AB and BC are the two sides of this triangle. So if I calculate this AC, I have to use the Pythagoras theorem, and with the help of Pythagoras theorem I can write this as hypotenuse square is equals to sum of the squares of the two sides. So here also I can write AC square is equals to AB square plus BC square. So I know that AC square is equals to AB is already given, that is nothing but 40, so 40 square. BC is already given, that is nothing but 30, so it will be 30 square. So 40 square will be 1600, 30 square will be 900. So here AC square is equals to, if I add this 1600 plus 900, it will become as 2500. So 2500 is nothing but AC square. But I want this AC, we have calculated this AC square, so there is a need that we should take the square root of this particular quantity. So after taking the square root of AC square, it will become as AC. So square root of 2500 is nothing but 25. So displacement of the object, displacement of this man from point A to point C, that is AC, is equals to 25 meter. Keep in mind that the unit should be given to the particular physical quantity. So here also the displacement is nothing, or magnitude of the displacement is nothing but 25 meter. You can easily see here that distance is 70 meter and displacement is nothing but 20 meter. So while discussing the theoretical part, we have already stated that it's not a necessary thing that distance and displacement will be same. Sometimes it is possible that distance and displacement may vary. So in this example you will come to know that you already came to know that distance and displacement sometimes these quantities are differ. Dear students, let us see the next problem. This problem is very important because this problem tells us about the distance and displacement when a circular type of track is considered. So we have seen in first problem, that is in the previous problem, we have seen that when a track is a straight line track. In second example we have seen that when the track is a rectangle track. Now this time let us see that if the track is of a circular one, then how the quantities can be calculated in terms of distance and displacement, how it is calculated. Let's try to understand it. Let us read the problem first. A circular bicycle track has a circumference of 314 meters. With AB as one of its diameters, a cyclist travels from A to B along a circular path with a velocity of constant magnitude 15.7 meter per second. Find A, distance moved by the cyclist, and B, the displacement of cyclist of AB represents north-south direction. Now let us see first what quantities are being given in this particular problem. Now this time the track is not a straight line, the track is not a rectangle one, but this time the circular track is a circular one. So we will draw a diagram. So I have drawn a diagram of a circular track. Let's imagine that the circle I have drawn is nothing but a circular track. Here is the point A, here is the point B. So if I join this line AB, then it will be nothing but the diameter of the circle. Okay, let us see what is been given here. A circular bicycle track has a circumference of 314 meters. Now circumference is nothing but if I start moving on this circular track, if I start from this point A and again reaches up to this point A again, then this total distance is nothing but the circumference. So I can write here as circumference is equals to 314 meter. Now with AB as one of its diameter, so we have drawn this AB as one of the diameter. We know that the upper side is nothing but north side and the lower side is nothing but south side. So I have represented here as this one is nothing but north side and this one is nothing but the south side. A cyclist travels from A to B. Now suppose the cyclist is traveling from A to B along the circular path. That means the cyclist is traveling in this direction. That's why I have shown the arrow over here. Okay, the cyclist travels from A to B along the circular path with a velocity of constant magnitude 15.7 meter per second. So first we have been asked to calculate the distance moved by the cyclist. Now the cyclist moved from A to B, and in this total path which is traveled by the cyclist from A to B along the circumference of the circle, that is nothing but this semicircular path. So what I will write here as, so distance traveled is nothing but circumference divided by 2. Now why I have written here 2? Because this is nothing but a half round completed up to this point B. So it is nothing but if I divide it by the total circumference in two parts, that is nothing but divided by 2, this will give me the distance traveled by that particular cyclist. So circumference is equals to 314 meter divided by 2. That means the cyclist starts from point A along this path, it reaches up to this point B. So here distance is nothing but if I calculate this 314 divided by 2, it will comes to be 157. So while the cyclist is moving from point A along the circumference up to this point B, then the distance traveled by the cyclist is nothing but 157 meters. Now let us see how we can calculate the displacement during the motion of the cyclist from point A to the point B. I know that displacement is nothing but the shortest path. So if I look carefully, this A if I consider as an initial point and B as considered as the final point, so the shortest path is nothing but this particular diameter of the circle. So I can write here as displacement will be is equals to AB, which is nothing but the diameter. So how I can calculate the diameter? From the formula of the circumference, I know that the circumference of any circle will be represented as 2 pi r, where pi is the value of 3.14 or 22 by 7. R is nothing but the radius of the circle. This circumference is already given. So what I will do, I will place the value of the circumference at this position of the circumference. So 314 is the 314 meters is the circumference of the circle. So I will keep the value of 314 over here, and right hand side I will write it as it is, 2 into pi into r. Now I am interested to calculate the radius, because once I am successful in calculation of the radius, then I can easily calculate the diameter also. So here r is equals to, now this r, in order to calculate this r, what I will do, I will shift this 2 pi into the left hand side. So since it is in multiplication, now if I shift this to the left hand side, then it will go into the denominator. So 314 divided by 2 pi, if I place the value of 314 divided by 2 into 3.14, pi is the value of 3.14. If I reshuffle this equation and calculation will be done, this will comes to the 50 meter. So this 50 meter is nothing but the radius. I have asked to calculate the diameter because this diameter is nothing but the displacement or magnitude of the displacement, which is nothing but the value of this AB. So diameter will be 2 into r, because I know that it is 2 times of the radius. So diameter will be 2 into r. So that can be written as 2 into 50 meter. that is nothing but 100 meter. So here the displacement is equals to 100 meter towards south. That means the object is moving from A to B. We know that displacement is a vector quantity, so that's why it is always necessary thing that it will be represented with the direction. So here also it is necessary to have the direction of that particular cyclist. So cyclist move from this point to this point. If I go on calculating the direction of this particular displacement, then this direction of the displacement is toward the south. So that's why I have to write here as displacement is equals to 100 meter towards south. South is nothing but this direction. Okay, so this was the interesting problem. Let us see some more problems in the next video. Thank you.